Okay, hello everyone. Today I'm gonna help you to do docking, and for that we gonna need some software. First, we're gonna need the Autodock 4.2. I'm gonna put the link in the description. This software we're gonna use to run the Autodock and the AutoGrid, and also to prepare our protein and the ligand. We're gonna use MGL Tools. Also, I'm gonna put the link in the description. Just you gonna download the version that you want. In MGL Tools, there is like two version. Both are good, but they note that like the 1.5.6 is more stable, but this one is like more recent. Also, we're gonna use the Bimol, for example, for the visualization, and also there is all other software like camera, and we're gonna talk about it later. Also, we're gonna need the open bubble, which is a program to convert your file from different version, and I will show you how to do that. Okay, to perform this docking, we're gonna go to the PDB database, and we're gonna download our protein, for example, to do this docking. And you can choose whatever you want. Maybe it's like you do some research in some protein, and you're gonna just put the ID here in your PDB. For example, I don't know, maybe you search for something uh, like um, um, uh, proteins do the oxidation, or maybe it's like some protein do the transport, and for that I'm gonna choose that 3-HTB. It's here. Okay, this is the our enzyme, the lysozyme. And to download the file, it's easy. Just go here and choose the PDB format here. For example, I'm gonna put it in the I am gonna choose the place, and I'm gonna just put the name, and you need to put the extension PDB and like this. And in the PDB here, the website PDB, you're gonna find like some information like the macromolecule here, some the small molecule, because we know in in this protein they they do like crystallography, and they stabilize the structure with some ligand. And for example, we're gonna find maybe some detergent, and maybe the other detergent and the other ligand. And for example, the ligand it's here, and you can find like some information like the binding affinity, and they do it from the assay. When you click here, maybe you're gonna find the article who's like working in this protein. Also, for example, we download our receptor plus the macromolecule that contain the ligand and other, and you can like download the ligand directly. It's like just click here. This is the ligand, and after that, like you download this ligand. There is like many format, and you're gonna choose, for example, the SDF, ideal SDF or model, and to use it directly, instead using PyMol to separate your ligand. And I'm gonna show you how to do it by PyMol, because I'm working like this. Okay, we're gonna go here. Okay, we're gonna open the PyMol. I opened already, and I put my ligand here, my receptor here, and I just wait. This is the file, the PDB file. When you go, you're gonna find the name here, and some information, for example. And after that, when you scroll down, you're gonna find like the residue, and at the end, you're gonna find the heteroatom, which is wait, yep. Yeah, the heteroatom, it's the ligand and other molecule that are used, for example, as a detergent, and you're gonna find many of them. And for the visualization, it's gonna be easy by Pymol, and I'm gonna show you how to do that. Just scroll your file here. Yes, yep. And as you see, it's like we can. I'm gonna open more, and for that, like we need to remove water. You can do it like this. Room action, you click in the action here. Action here is show, hide, and labeling. Okay, action, remove water. Okay, you know, it's like the the red point is the our water molecule, and we're gonna click here display to see the sequence, and our protein is here, our ligand is here. We can remove this one and the BMO because we don't need it. Okay, to remove it, like you can click here and click click with uh, um, your buttons, like right and remove. And if not, you can directly select the ligand and delete with other things. And to next, we're gonna do the same for the ligand. We need to extract our ligand from the receptor to do this docking. And you click here, select, for example, you can go to the selection here or here. It's the same, and you need like to extract. I'm gonna do it again. Okay, come back. Okay, just select the ligand and click action or directly from here and extract your ligand. It's here, it's named new object one, and we're gonna rename it. Click action and rename your object, and we're gonna just give it a name GZ4 and click Entrée. Okay, we have our now it's like the ligand separately to the protein, and for that we need just export our molecule. To export the molecule, it's easy. Just go to export and select first. You're gonna select um, the receptor alone because he have this name, and we're gonna save it as PDB. I put like everything in the same file, 3 HTTP. I'm gonna just put P for or clean point PDB. And again, we're gonna select next the ligand, save. Okay, G GZ4. Okay, and click OK. For now, we're gonna need we don't need this one. And next, we're gonna need open bubble to convert our ligand from PDB to the PDBQT file because we need this format to perform docking. Okay, okay, this is the open bubble. We're gonna open our file and just you draw here your ligand, or you can like go here and find your way. Okay, we're gonna select because I know it's like here this is a PDB file which he is here, and okay, and this is you're gonna choose your file, and after that the output you're gonna put the place, and we're gonna just name it, save it. I forget the name. Yeah, GZ4 GZ4 PDBQT. Okay, and convert, and as you see we have our ligand. And next we're gonna open this one, which is MGL Tools. I'm gonna use this version 1.5.7. Why? Because I don't know, it's like I use it many time and I find it's like in the visualization it's more easy, and it's new more than the last one, and there is like small differences, for example, and there is like two or three option compared to the first one. And to perform docking, we're gonna prepare our receptor. We're gonna read the molecule, and we're gonna select this one because it's the clean version. Okay, it's here. We're gonna change the form, and I prefer this like this. You can change color here from here. First, we're gonna check the missing atom. Mm, you're gonna go edit, mask, check the missing atom, and we're gonna select all and dismiss. Next, we're gonna repair the missing atom. This one, it's gonna take a few minutes maybe. It depends on your protein. Maybe if you have like a big receptor, it's gonna take between 3 minute maximum. And after that, I'm gonna show you how to do the next, and we need to add the charge and add also the hydrogen molecule. As you see here, it's finished, and you're gonna save as set to and click dismiss. Next, we're gonna add the hydrogen, and you need to select only the polar only because the polar hydrogen can interact or maybe it's like use it to interact with the ligand. Also, we're gonna add the charge for our molecule. Click the Coleman charge and save it. Okay. Next, now we're gonna prepare our ligand. Okay, I'm gonna just yes up to read the ligand. You click here, input, open, and we have the ligand here. And as a default, like you're gonna like see the name and the number of torsion is 2, rotatable bond. And next, we're gonna detect the route, which is the first molecule or the first atom in our ligand, and also set number of torsion. Here, as you see, there is 2, and maybe it's like you can unlock your torsion to do it's like 0, and there is no rotatable bond in your molecule. But we're gonna left it as it's like with 2. And next, we're gonna prepare our grid box. For that, like we need to select the macromolecule. If you already like have your receptor in PDBQT format file, because if you like have many ligand and you prepare once you prepare your receptor, you're gonna save it as PDBQT file, and next times like you're gonna just open it without like doing here like this. We're gonna choose it, and we're gonna choose here, select, and okay, we're gonna click OK, and I'm gonna just change the name up, and the extension is a PDBQT format file. Okay, next we're gonna set map for set map type, and we're gonna choose the ligand here. And next we're gonna choose the grid box. As you see here, this is like the default parameter, and I prefer like here we're gonna do 0.5. It's okay. Sometimes like they told you like the best is 60 to choose 60 as the dimension. If you know it's like you need to to do it like many times to see the difference, because sometimes like 60 as dimension is good for you and sometimes it's not, and it depends on your what you searching for. And sometimes like you can do blind dockings, like just uh, um, you can maybe it's like you cover all your protein, and it depends if you don't know the I don't know if you don't have maybe a site active site in your, you don't know the active site, and it's preferable to do like a blind docking. And just the center, I'm gonna use the ligand center here, and because I know it's like the ligand it's here, here, and just click here to center your box in the ligand, because we know already this ligand it's binding here. And we can save, sometimes I'm do it's like save your grid box as text file for next, for example, and close the saving current. After that, output your G, or of GPF, which is the grid parameter, and I put the name one GPF. Okay, save it. You can say it's like here, see the edit GPF, or you can see the parameter, which is the number of the point, which is the dimension and the spacing, and you can also see the uh, other things like the map and other information that are necessary. Okay, next we're gonna go read run AutoGrid. For that, we're gonna browse here the program. We're gonna search for it. This the two are necessary to um, for your to run the AutoGrid. And I'm gonna put the link of in the description how to download the both. And click, we're gonna choose the AutoGrid, and after that we're gonna file and choose the GPF. Okay, run. It's gonna take a few minutes. Next, we're gonna go docking. Now we're gonna set the docking parameter, and for the macromolecule we set as a rigid, because we're gonna do with only the ligand move around. Okay, select the receptor. Next, for the ligand, choose, and we're gonna choose our ligand. Okay, and this is the default parameter. You just click OK. After that, docking search parameter, we're gonna choose the genetic algorithm. um, Here first we're gonna choose some parameter, for example here the number of run. Sometimes like I do 20 just for this video, but sometimes I prefer 50 or maybe 100, but it's not um, the number of run. You can say it's like you're gonna have the same result, but the research it's more better if you have like 100 run than 20. And for population size, I'm gonna go with 300, which is better to give like your algorithm more population to search for, and your research is gonna be better. And we're gonna let all the other parameter as a default. Next, we're gonna output our uh, DPF, which is output, and we're gonna click Lamarckian algorithm, which is an algorithm for local research, and just save it as 1.dpf. DPF, it's a docking parameter file. Okay, I think now we're gonna run our Autodock here. The same, like uh, just select the program, which is here, or Autodock, and next, okay, we're gonna choose the DPF and just launch. What I forget to say, it's here before it's like starting here. I didn't mention that. It's like you need to click File, Preference, Set here, and it's like you need to put to when you read your first molecule, you need to put the link of your file. For example, um, I'm gonna show you. For example, here you just click here and put the link. For example, here, and open again and put the link here and set. We make it set and make it default, because when you read your molecule in the beginning, it's gonna open directly the file, and maybe you can change it next, like if you have another file or to work on it. Okay, I don't want to have like a big video, but I'm gonna show you just how to analyze your file. Here, it's like after your docking, you have like many file, and you're gonna open your DLG file here, open it, and you're gonna search for something here, search for RMSD, and here we're gonna just know this is the lowest energy and the number of run, it's one. To we're gonna just memorize this one to know which one as run to save it for the analyze. Okay, we're gonna open the MGL tools, we're gonna just delete this one because we don't need it, and go to analyze docking, open. We're gonna open the DLG file um, with default, and after we're gonna choose the macromolecule, it's gonna find it inside directly. And okay, I'm gonna just change the visualization and go next, go to the confirmation and play. And as you see here, okay, all the times like you need to select your ligand because I don't know, it's deselected. Okay, there is here you can, I don't know if you can see uh, the ligand, it's moved when we change the, okay, here you can see it's like moving but a little bit. But our best binding or score, it's the run one. And next you're gonna click here, here, open the panel to change the play option. Okay, and we're gonna just write, you can write all, but when you click here, you're gonna only save this pose with your receptor, and we're gonna go with complex .pdb qt file. Okay, okay, we save it, and I'm gonna show you. It's okay, complex. I'm searching for complex. I don't know. Wait. I- Yeah, it's here. And next we're gonna open the Pymol, as you see here, just to do the visualization, and we're gonna delete everything. Okay, and just draw your new docking file, uh, and you can see here our ligand, it's inside. And if you want just like to analyze like quickly with Pymol, you're gonna go with action, reset, ligand site, and cartoon to see like the interaction inside. And maybe I'm gonna do another video to show you how to analyze your structure uh, with Paymol. If you have any other question, you can you can pose it in the comment section, and I'm gonna let some something to when you, if you want to ask me about thing. And maybe the idea is like to share information between us. And also, I'm not gonna lie, I'm learning, and I hope like to have more question to learn more. Thank you.